An interesting question: why do the planets appear to be on a plane, even though there is no plane in space? The sun's gravity pulls equally in all directions, meaning there is no plane provided by the star. In fact, the moons of the planets, asteroids, and many comets also move on this plane. But why? To understand this, we need to go back billions of years, long before the planets existed, even before the sun. The solar nebula that formed the solar system 4.5 billion years ago was a messy, chaotic, cold cloud formed by a supernova. This cloud was mostly made up of hydrogen and helium. And when we look at it, there was no plane in this cloud, meaning that messy planets must have formed. However, the solar nebula was not as immobile as we thought. It probably had some rotation in the beginning, perhaps due to nearby exploding stars or gravitational interactions with other clouds. When gravity started pulling this huge cloud inward, something very important happened. One of the simplest rules in physics came into play. The messy cloud flattened out due to the conservation of angular momentum. Think of pizza dough. As you turn the dough, it expands and flattens. Over millions of years, this rotating, flattened cloud continued to collapse. Most of the mass concentrated in the center and eventually ignited, forming our sun. The remaining material formed a disk that orbited the young sun, called a protoplanetary disk. Inside this disk, countless particles of dust and ice were constantly colliding. Because of the relatively flat structure of the disk, these collisions were more likely to occur within the plane of the disk than at random angles above or below it. The temperature gradient also played a significant role in this disk. Because the side closer to the sun was naturally warmer, water vapor migrated to the back and glaciated. This structure later formed the identity of the planets. Over time, these small particles began to stick together through electrostatic forces and gravity. Larger clumps formed, and the architect of the universe, gravity, created planetoids. Since the initial dust and gas were concentrated in the flat disk, the growing planetoids were also confined to this plane. As they orbited the young sun, they swept up more and more material along their orbital paths, further solidifying their orbits within the disk. In the warmer inner regions of the disk, where ices could not condense, collisions between rocky planetoids led to the formation of the smaller rocky planets we know today: Mercury, Venus, Earth, and Mars. In the colder outer regions beyond the frost line, icy planetoids were able to accumulate large amounts of frozen volatiles such as water, ammonia, and methane. These icy cores then gravitationally pulled in the abundant hydrogen and helium gas in the outer disk, giving rise to the gas giants Jupiter and Saturn. Farther out, Uranus and Neptune formed in a similar manner, but they captured less of the lighter gas. So after billions of years of this process, the planets in our solar system began orbiting the sun in a relatively flat plane known as the ecliptic. Now, it's important to note that the planetary plane is not perfectly flat. Some planets have slight tilts in their orbits. This could be due to later collisions with larger objects or gravitational interactions with other planets over large timescales. For example, the formation of our moon is a prime example of a major early collision. The prevailing theory holds that a Mars-sized object, usually called Theia, collided with the early Earth. The debris thrown up from this cataclysmic event coalesced to form our natural satellite, and this collision probably also affected the Earth's axial tilt, another planet that is out of plane, or rather, the dwarf planet Pluto. In fact, this is one reason why Pluto is considered a dwarf planet instead of a planet: its strange tilt. It sometimes even orbits perpendicular to the ecliptic. So why doesn't Pluto move in a plane? Because not everything formed in the disk. Some objects were thrown around. Some came from the Oort cloud, far out in the solar system where things are more chaotic. In the collisions in the Oort cloud, icy asteroids that were ejected from orbit travel inward as comets. Some hit Saturn or are captured by Pluto. Pluto was probably a space rock made up of ice. It merged with icy rocks from the Oort cloud and formed a dwarf planet. However, the overall structure is still remarkably flat. So was the initial rotational acceleration of the sun a fluke, or is it the same for all stars? When we look at other stars, they have a plane like the sun. In other words, dust clouds in space accelerate and form pizzas, but each nebula and each star have different gravitational and rotational speeds. In other words, each star forms a plane, but they do not form the same planetary disk. For example, things get even more complicated in binary star systems. The planet is pushed out of the disk and random planetary orbits are formed. So what would happen if the stars did not form a plane? It would be complete chaos. The absence of a plane would mean that one planetary orbit would affect the other, and the planet would collide, be thrown out of orbit, and its orbit would be more oval. So, if we think about the Earth's orbit is almost circular right now. Therefore, its distance from the sun does not change much throughout the year. but in an oval orbit, summers and winters are much harsher. Temperature differences make the Earth desert. Rapidly melting glaciers cause floods on Earth. In short, if the sun did not form a plane, there would probably be no life on Earth. So, the next time you look at a model of our solar system, remember the huge rotating cloud of gas and dust that gives life to everything. The flat plane of our planets is a beautiful demonstration of the basic laws of physics, especially the conservation of angular momentum. I hope you enjoyed the video, and don't forget to subscribe to the channel for more extreme science videos. Thanks for watching. Bye!